Hi there. Welcome to the video about volume by cross sections. If this is the first time you're seeing my face, hi, my name's Dr. Marissa May. I am on a mission to help students feel confident in their math class. So, this video, along with other resources or tools, share with students and families so that they're able to feel that confidence to be successful in their math class. That being said, don't forget to hit that like and subscribe button. That way, you get a notification every time a new video is posted. And also, feel free to send me a DM on one of my social medias. Leave me a comment below. I would be happy to help in any way that I can. This video, though, we are going to be looking at volumes of cross sections, and I want to let you know from the very beginning, I'm going to focus on setting up the integrals for this. I'm not going to spend a lot of time on actually calculating the integral. If I'm going to leave it for you to work on the antiderivative or put it in your graphing calculator, I will share the answers with you. That way you can check that, but just know I'm not going to take time in this video to go through the mechanics of the antiderivatives for these integrals. We're really going to focus on setting up the integrals. So for this video, we are focusing on volumes by cross section. Now, if you missed my videos on volumes by rotation, I'll be sure and link those below so that you can look at them. It's the two ways we take the volume in calculus. So this volume is going to be taking a two-dimensional shape. Notice the graphs here, and then having cross sections to create a 3D shape. Now, those cross sections can be a number of shapes here, but we're going to focus first on squares, and then I'll do isosceles right triangles. I want you to see how the cross sections, though, sit. Notice in this cross section that the squares are sitting perpendicular to the x-axis. They don't actually touch the x-axis, but they are perpendicular. It'll be important for you to know if they're perpendicular to the x-axis or the y-axis, because that's going to dictate if you're going to do your integral in terms of x or y. So let's jump in. When we are looking at finding the volume by cross section, the first thing you want to do is to look at the actual two-dimensional shape of that cross section. So what we've done is we've taken a square here and we've laid it out. Notice that my square runs from one curve to the next. So in order to get that length of that side of the curve, we would do the top curve minus the bottom curve. In this case, that is f of x minus g of x. Now, you and I know that squares have the same sides. So if this is f of x minus g of x, then we know all of the sides are f of x minus g of x. So in order to get the area of this square, we would say that would be f of x minus g of x and then squared. So realize what I did is I took the cross-section shape, I laid it out in a 2D shape, and I wrote a formula for with a side that sits in that between the two curves. Now, if all of the cross-section areas were added up, that would be the total of the volume of the solid. And how do we do that in calculus? Well, we do that by the integral. So we take the integral and we add up all the areas of those squares. So that's the big takeaway I want you to get from this, that if we want to find the volume with cross sections, we take the integral of the area. Now, that area formula is going to look different depending on the shape. For instance, in this one, you have your cross sections are isosceles right triangles. Notice that your right triangle sits between the top curve minus the bottom curve. Notice we've laid out the isosceles triangle showing the top curve minus the bottom curve as the sides. And that area then would be, area of a triangle is 1/2 base times height. That would be, in this case, 1/2 times, now both the base and the height, they're the same in an isosceles triangle. So that would be f of x minus g of x squared. And then again, if we want the volume, of course, we're going to write the integral. Okay, let's keep going then and look at some more shapes. So if we do equilateral triangles, the equilateral triangles running from the top curve, bottom curve, lay out the equilateral triangle. The formula for the area of an equilateral triangle is square root of 3 over 4 times the side squared. It's going to be one you want to know because we see that one show up. And of course, you don't get a formula chart on the AP exam. And so notice the side, I've just replaced that with f of x minus g of x. So if you want that volume, then we do the integral from a to b, square root of 3 over 4, and then it's f of x minus g of x squared dx. Now, the semicircles and quarter circles get a little interesting. So you have to be real careful as to what is the radius. So notice that the semicircles sit from top curve minus bottom curve. That's your diameter, okay? So in order to find the area here, we know the area of a semicircle, 1/2 pi r squared. But the f of x minus g of x is the diameter. So we've got to cut that in half also. So I've got 1/2 pi times, now I've got f of x minus g of x, but I've got to cut it in half, and then I have to square it. So a lot of students get confused on this one because they think this half takes care of the cutting the diameter in half, but this actually is because of the semicircle. The one in here is the one for cutting the diameter in half. So again, if we want the volume, we do the integral from a to b of the area 1/2 pi f of x minus g of x divided by 2, then squared dx. Okay, let's put actually some functions in there this time, okay? So we're going to work with the curve bounded by sine of pi x and x cubed minus 4x. I've got a graph here. And we want to find the volume of the solids formed by the cross sections we're given, and they are perpendicular to the x-axis. So realize that whatever the shape is, it's going to sit here perpendicular to the x-axis there. So first we want to do equilateral triangles. I like to draw the picture of it. It's an equilateral triangle. And this side right here is from this curve, which is your sine of x curve, sine of pi x, and then it runs to your x to the third minus 4x. So that side is sine of pi x minus x cubed minus 4x. Notice the minus has to be distributed. And then I know the area is the square root of 3 over 4 side squared, which in this case would be sine of pi x minus x cubed plus 4x, and then we've got to square it. So let's write the integral. We are going from 0 to 2, 0 to 2, square root of 3 over 4, sine of pi x minus x cubed plus 4x, then squared dx. Now remember, I said I wasn't focusing this video on the antiderivatives or putting that in the calculator. I am going to tell you the answer you should get. If you want to check that, you definitely can. Okay, next let's do semicircles. So semicircles, remember, this is your diameter. That is your same equation for the diameter. Okay, so your area is going to be 1/2 pi r squared. But we're going to have to take this diameter and cut it in half again. So I've got sine of pi x minus x cubed plus 4x. Then I got to divide it by 2 and then square it. Okay, so my volume is the integral from 0 to 2, 1/2 pi, and then I've got sine of pi x minus x cubed plus 4x over 2, and then square it dx. And for that one, you should get 3.918. Okay, next let's do an isosceles right triangle. This is what is sitting perpendicular to the x-axis, so that is your sine of pi x minus x cubed minus 4x. And then so my area would be 1/2 times base squared because the base and the height are the same. And so we'll put that equation in there. I've got sine of pi x minus x cubed plus 4x, and then we square it. So my volume goes from integral from 0 to 2, 1/2 sine of pi x minus x cubed plus 4x squared dx. And if you put this one in your calculator, you should get 4.989. I'll let you do that. All right, next let's do squares. Squares, sorry, I drew my rectangle. I drew a square to look like a rectangle. It should be a square there. So I've got sine of pi x here minus x cubed minus 4x. So we know the area of a square is side squared, and our side is the sine of pi x minus x cubed plus 4x, and we square it. So our volume is the integral from 0 to 2 of the area formula, sine of pi x minus x cubed plus 4x squared dx. And for that one, you should get 9.978. All right, just two more to go. Now for this one, we have the cross sections are rectangles whose height is twice the length of the base. So when I draw this, what we're saying is that our base is the sine of pi x minus x cubed minus 4x. But we're also saying the height is 2 times that. Let me scoot this over so you can see it. So when we write our area would be length times width, which in this case would be the sine of pi x minus x cubed plus 4x times 2 times that. So it'd be 2 times sine of pi x minus x cubed plus 4x. So essentially our area is 2 times the sine of pi x minus x cubed plus 4x squared. And so my volume here will run from 0 to 2 of that area formula, 2 times sine of pi x minus x cubed plus 4x, square it dx. And for that one, you should get 19.959. Okay, now if we look at the final one here, we're going to use rectangles, but this time the height is 1/3 the length. Okay, so instead of having 2 times this, we're going to have 1/3. Instead of having 2 times this, we'll have 1/3. You get the idea. So I'm not going to draw this one. I'm just going to say my area would be 1/3 times our function minus x cubed plus 4x squared. We still do the volume the same way with the integral, going from 0 to 2 of 1/3 sine of pi x minus x cubed plus 4x squared dx. And for that one, you should get 3.326. So I hope that helps with the volume of cross sections. Focus on that area. Draw your shape as you need to. Then find your area formula and substitute in your top curve minus your bottom curve. And we may do some more in another video where the cross sections run perpendicular to the y-axis. That just simply means you're going to do your curves your integral in terms of y. But I'll be sure to add some examples of those so that you get to practice with them. Friends, thanks so much for watching. I enjoyed it. If I can help in any way, please feel free to leave a comment below. Bye for now.